Hello viewers, welcome to my channel. Today we're picking up from where we stopped on our last video where we discussed on the definition of surd, rules guiding the basic operation of surd, reduction of surd to basic form, and expressing surd as a single surd. If you're joining us for the first time, I'll be dropping the link to the introduction of surd in the description box below. Now let's start with what we have for today. Today we'll be looking at basic operation of surd. And the first thing we're going to do today is on the addition and subtraction of surd. Now, before we go into the examples we have in this class, let's take note of some points that will guide us. Now, similar surd can be added together or subtracted from each other. So before we can add surds together or subtract them from each other, we must ensure that they are similar. So before addition or subtraction, the surd should first be simplified. So in our last video, we simplified surd to their basic form. So before we can add or subtract surd, we must ensure that it is simplified to their basic form, if possible. So the if possible here is some cases the surd or the question will be given to you in their simplified form. In that way, you just need to add and subtract. But in a situation where it is not simplified, we have to simplify it first using the method we use to simplify surd to their basic form. Now, examples of similar surd are we have a root x, b root x, c root x. So we'll classify this surd as similar or like surd because they have the same roots. We have root x, root x, root x. So if we are to do a root x plus b root x plus c root x, we're going to pick one of the root x because they are similar. Then we'll do a plus b plus c, which will give us a plus b plus c root x. Another example can be, let's say we'll have 1 root 2 plus 2 root 2. You agree with me that root 2 and root 2 are similar. So we can just say 1 plus 2, which will give us 3 root 2. So this is an example of similar surd. Y surd of the form a root x, b root y, c root z are not similar and cannot be added or subtracted from each other. For instance, we have 2 root 3 plus 4 root 5 plus 6 root 7. Because of the roots, we have here root 3, we have here root 5, and we have here root 7. They are not the same. So we'll classify this surd as not similar. They are unlike surd. So we cannot add, neither can we subtract them from each other. So now that we've taken note of this, let's move to the examples we have for today. So in today's class, on the addition and subtraction of surd, our focus will be on similar or like surd. We're going to solve an example under the similar or like surd and unlike surd, which are the surds that are not similar. So that we're going to see how to apply the rules of surd in solving this kind of question. That's the rule of similar surd should be added together, and unsimilar surd or not similar surd should not be added together. So we're starting with the similar surd before we move to the unlike surd. So under the similar surd, we have 5 examples. Under the unlike surd, we have 3 examples. Now let's start with example 1. Example 1, we have 4 root 2 plus 6 root 2. So if you take a look at this question, we see that the root 2 for the first number and the second number are actually the same. Root 2 is root 2, so they are similar. That is one thing you should note. And another thing is they are actually simplified to their basic form. We can no longer break root 2 to a more simpler form, no, because the root 2 is not a perfect square, so we cannot find the square root of 2. So now that this is actually settled, it is simplified and they are similar surd. Now let's add them together. So what we're going to do is this, just like in algebra, where we have 4x plus 6x. We're going to take 4 and 6 together, right? Which is going to give us 10. So 4 plus 6 is 10. Then what is the variable here, or the letter? The letter we have here is x. So it remains as x. So 4x plus 6x gives us 10x. So just as in algebra, we can actually use this method and apply it to surd. So which is 4 plus 6, we'll bring it in a bracket, 4 plus 6, and then because the root 2 are actually like 10, they are similar, we're going to just use only one, root 2. Now 4 plus 6 gives us 10, 10 root 2. This is the answer for number 1. For number 2, we'll have 3 root 5 minus 7 root 5. So under this number 2, we also have the same root, so it is similar surd. Now we're going to bring out the numbers together. So we'll have 3 minus 7 in a bracket root 5. 3 minus 7 gives us minus 4 root 5. So this is the answer for number 2. So we are starting from the simplest to the complex. So for question number 3, we'll have root 50 minus root 18 plus root 32. So looking at this question, we observe that it is in a single surd, that is a complex surd. So the first thing we're going to do here is to simplify them or reduce them to their basic form. Then after the reduction to their simplest form, we can now add or subtract. Now for roots 50, 18, and 32, we have to look for factors. That's two numbers and we will multiply them together. One will be a perfect square and the other will be in a simpler number. So for root 50, we can break it down and factor it into 25 times 2. So whereby 25 times 2 gives us 50, but we can get the square root of 25, which will give us 5. Now we'll move to 18. So minus 18, 18 gives us 9 times 2 plus 32 gives us 16 times 2. So if we observe, 9 is a perfect square and 16 is also a perfect square. So now we are going to split this. Root 25 times root 2 minus root 9 times root 2 plus root 16 times root 2. This is from the rule of surd, whereby if we multiply a number under the same surd, if they are under the same surd, if we multiply them together, when we split them and multiply them, they are also the same thing. So root 25 times 2 is still the same as root 25 times root 2. So now let's continue. This is equal to root 25 is the same as 5. So square root of 25 is 5 times root 2, which is root 2, minus square root of 9 is 3 times root 2, which is root 2. Now plus square root of 16 gives us 4 root 2. So this is 5 root 2 minus 3 root 2 plus 4 root 2. So now we have broken this down to their simplest form. So the next thing we're going to do is to subtract and then add. So we're going to be bringing out these numbers and keep the root form separately. So if you notice, the roots are actually the same. So this is a similar surd. Root 2, and root 2. They are similar. So I'm going to be picking one and then bringing the numbers and the signs together. So which is 5 minus 3 plus 4. We'll put it in a bracket, then root 2. So this is equal to 5 minus 3 is 2, and 2 plus 4 is 6. 6 root 2. This is for example 3. Now let's go to example 4. So for question number 4, we'll have 2 root 150 minus root 96 minus 2 root 24. So the first thing we're going to do here is to also break this down to its simplest form. So we have to reduce it to the basic form before we can subtract the following surds. So we'll have 2 root 150. So now we'll have to look for what we can break 150. We can actually factor 150 and bring out two multiples, which are, I'll be working with 25 times 6. 25 is a perfect square and 6 is in the simplest form, minus 4 root 96, let's use 16 times 6, minus 2, for root 24, I'll be working with 4 times 6. So if we observe, everything here is a factor of the number above. 25 times 6 gives us 150, whereby 25 is the perfect square. 16 times 6 gives us 96, whereby 16 is a perfect square. And 4 times 6 gives us 24, whereby 4 is a perfect square. So the next thing we're going to do, we're going to split this into separate surds. So we'll have 2 root 25 times root 6 minus root 16 times root 6 minus 2 root 4 times root 6. So now we have to look for the square root of the perfect squares. 2 times, what's the square root of 25? It is 5. Then we'll have times root 6 minus the square root of 16 is 4, then root 6 minus 2 times the square root of 4 is 2, then times our root 6. 2 times 5 gives us 10, then root 6 minus, we'll have 4 root 6, and then we'll have 2 times 2 gives us 4. 4 times our root 6 is 4 root 6. If you'll observe, this 2 outside here actually came with the question, so we're going to multiply it to the square root of the number we get. So the 2 outside times the square root of 25, which is 5, gives us 10. Now we'll notice this is already in its simplest form. So after we've broken it to the simplest form, we now have to subtract. So looking at the surd, the square root of 6, square root of 6, square root of 6 are similar, they are the same. So we're going to pick one and then subtract the values. So this is 10 minus 4 in a bracket, then root 6. So 10 minus 4 gives us 6, and then 6 minus 4 gives us 2. So 2 root 6. This is the answer for question number 4. Now let's move to question number 5. So for question number 5, we'll have 2 root 135 minus 2 root 60 plus root 15 minus root 240. Now let's break this down to their simplest form. One will be a perfect square and the other a simple number. So now we'll have 2 root 135. For me to get two numbers, that's two multiples of 135, I'll be working with 9 times 15. 9 is a perfect square and 15 is a simple number. So we'll have minus 2 roots. For 60, I'll have 4 times 15. Then here we'll have plus 15, plus root 15, minus root. For 240, the factors I'll be working with is 16 times 15. So now we can see that all of them has root 15, 15, 15. So looking at this from this angle, we can see it's a similar surd. So now let's continue by splitting the surd. So 2 root 9 times root 15 minus 2 root 4 times root 15 plus root 15 minus root 16 times root 15. So the next thing is to look for the square root of the numbers of the perfect squares. So the square root of 9 gives us 3. So 2 times 3 root 15 minus 2. The square root of 4 gives us 2. Then we'll have our root 15 plus root 15 minus the square root of 16 gives us 4 times our root 15, we'll have root 15. So 2 times 3 gives us 6 root 15 minus 2 times 2, 4 root 15 plus root 15 minus 4 root 15. So we'll have root 15, 15, 15, 15 in the numbers, so they are similar. But don't say 15 can actually still be broken down. If we break it down, it will give us 3 times 5. If you look at the number 3 times 5, 3 is not a perfect square, 5 is not also a perfect square. So we can actually leave it as root 15, which will be our simple surd here. It will be our basic form here. So in that way, it is already in a simple surd. So now let's bring it together. Let's bring the numbers together and have our surd. That's just pick one of the surd separately. So this is 6 minus 4. Here there's an invisible one. It's just like in algebra, wherever we have x, there's an invisible one, which is 1x. So now this is 1 root 15. So we'll have plus 1 minus 4. Then the root 15, we're going to pick 1. So 6 minus 4 gives me 2 plus 1 minus 4. Root 15, do not forget that. Now 2 plus 1 gives us 3 minus 4 root 15. Now, final answer is 3 minus 4 is minus 1. So, minus 1 is the same as minus. So, minus root 15 is the answer for this question. So, just like saying minus 1x, it's still the same as minus x. So, this is the answer. So, now we'll be looking into the unlike surd. Here, we'll be working with surd that are not similar. So, the first example under this is number 1, we'll have 4 root 72 plus 5 root 12 minus 3 root 18 plus 2 root 75. So for those under the roots, we'll notice they are not in their simplest form. So let's break it down to basic form. Then after that, we can add and subtract and also take note of the like and unlike surd. So this is 4 root 72. When we break it down, we'll be having 36 times 2. 36 is a perfect square and 2 is a simple number, plus 5. Under root 12, we'll get 4 times 3. Then we'll have minus 3. For 18, we'll have 9 times 2 plus 2. For root 75, we'll have 25 times 3. Now let's separate the perfect square from the simple surd. Root 36 times root 2 plus 5 root 4 times root 3 minus 3 root 9 times root 2 plus 2 root 25 times root 3. Now let's look for the square root of the perfect square. 4 times the square root of 36 gives us 6. Then we'll have our root 2 plus 5 times the square root of 4 gives us 2. Then we'll have our root 3 minus 3. The square root of 9 gives us 3. Then we'll have our root 2 plus 2. The square root of 25 gives us 5. Then we'll have our root 3. So multiplying the numbers together, 4 times 6 is 24 root 2 plus 5 times 2 is 10 root 3 minus 3 times 3 is 9 root 2 plus 2 times 5 is 10 root 3. So if we take note of this question, if we observe, we'll see that root 2 is here, root 2 is also here, root 3 is here, root 3 is also here. So root 2 and root 2 are like terms, root 3 and root 3 are also like terms, but root 2 and root 3, they are not like terms. This is where the unlike surd comes in. So now let's collect like surd. Collect like surds. Now 24 root 2 and minus 9 root 2 are like, so we're going to bring them together, minus 9 root 2. Then we'll have plus 10 root 3 plus 10 root 3. So now we're going to subtract these two and then add these two together. So 24 root 2 minus 9 root 2, that is 24 minus 9. Then we're going to put it in a bracket, then our root 2 plus 10 plus 10 in a bracket, then our root 3. So 24 minus 9 gives us 15 root 2 plus 10 plus 10 gives us 20 root 3. So I'm going to leave my answer here because the root 2 and the root 3 here, they are not alike, they are not similar. So this is how we're going to end our answer as unlike surd. So 15 root 2 plus 20 root 3. It is going to end there because the root 2 and the root 3 are not the same. It's just like saying 10y plus 3x. Can we add them together? No, it's not possible. So now let's go to number 2. So for number 2, we have 3 root 20 minus 3 root 27 plus 3 root 45. So let's break this down to the simplest sort. 3 root, for root 20, we have 4 times 5 minus 3 root, for 27, we have 9 times 3 plus 3 roots. For 45, we have 9 times 5. Now let's split the surd. 3 root 4 times root 5 minus 3 root 9 times root 3 plus 3 root 9 times root 5. So look for the square root of the perfect square. 3 times root 4 is 2 root 5 minus 3 times square root of 9 is 3 root 3 plus 3 times the square root of 9 is also 3, then root 5. 3 times 2 will have 6 root 5 minus 3 times 3 will have 9 root 3 plus 3 times 3 will have 9 root 5. So we will have to collect like surd. So collecting like surd, we'll say that 6 root 5 and 9 root 5 has the same surd. So we'll bring them together. 6 root 5 plus 9 root 5. Then we are left with minus 9 root 3. So adding these two together, 6 plus 9 in a bracket, we'll have our root 5 minus 9 root 3. So 6 plus 9 will have 15 root 5 minus 9 root 3. So we're going to stop here because we no longer have any like surd. We'll have here root 5 and we'll have here root 3. They are not similar. So this is where we're going to stop, and this is the answer for number 2. Now let's go to number 3, which is the last question here. Number 3, we'll have 7 root 128 plus 5 root 363 minus 2 root 98 minus 2 root 972. So let's break this down to their simplest surd. 7 roots. For 128, we break it down to 64 times 2 plus 5 root. For 363, we break it down to 121 times 3 minus 2 root. For 98, we break it down to 49 times 2 minus 2 roots. For 972, we break it down to 324 times 3. Now let's split the surds. 7 root 64 times root 2 plus 5 root 121 times root 3 minus 2 root 49 times root 2 minus 2 root 324 times root 3. Now let's look for the square root of the perfect squares. So this is 7 times 64. Square root of 64 gives us 8 root 2 plus 5 times square root of 121 gives us 11 root 3 minus 2 times root 49 we have 7 root 2 minus 2 root 324 gives us 18. Then we'll have our root 3. 7 times 8 will have 56 root 2 plus 5 times 11 will have 55 root 3 minus 2 times 7 will have 14 root 2 minus 2 times 18 will have 36 root 3. So what we're going to do is root 2 and root 2, these are like surd. Root 3 and root 3, these are like surd. So collect like surd. 56 root 2 will go with minus 14 root 2, then plus 55 root 3 will go with minus 36 root 3. Now 56 minus 14, we'll bring it together, then we'll pick one of the root 2 plus 55 minus 36, we'll bring it together and pick one of the root 3. So 56 minus 14 gives us 42 root 2 plus 55 minus 36 gives us 19 root 3. So this is our answer because we no longer have any like term. So these are unlike term, we cannot simplify them together, we cannot add them together. So this is the answer for number 3. This is the last question in this video. If you have any question concerning addition and subtraction of surd or any other question relating to surd, you should drop it at the comment section. I will reply to them. Thank you very much for joining me in today's class. See you in my next class. Bye.